There are 6 boys and 5 girls in a school tennis club. A team of 2 boys and 2 girls will be selected. A. In how many different ways the team can be selected? So we should choose 2 boys out of 6 and 2 girls out of 5. And the question is it a number of combinations or a number of permutations? Since we need 2 boys and we don't distribute some duties between them, it will be a number of combinations, not permutations. If a question would be to choose 2 boys and to be a player number 1 and a player number 2, it means that we distribute some duties between them and it would be a number of permutations. But here we choose like indistinguishable objects, order, and order doesn't matter here. So it's a number of combinations, and the number of ways to choose 2 boys out of 6, it's a number of combinations 2 out of 6. Notice that you may meet such notation for combinations like this, 2 out of 6. Don't get confused. And implies multiplication because it's one event, 2 boys and 2 girls to be chosen, 2 events which are connected by and its multiplication at the same time. Number of combinations to choose 2 girls out of 5. You may calculate it using a calculator. I can use a formula. 6 factorial, 2 factorial, greater minus the greater minus the smaller, 6 minus 2, it's 4 factorial, it becomes 5, 6, 3, so it's 15. Number of combinations 2 out of 5, 5 factorial, 2 factorial, 5 minus 2, 3 factorial, 4, 5, it's 2, times 5, it's 10. So the total number of different ways, it's 150. B. Tim is the youngest boy in the club and Anna is the youngest girl. In how many different ways can the team be selected if it must include both of them? So Tim should be chosen and Anna should be chosen, but we still need 2 boys and 2 girls. So if Tim is already chosen, we need 1 remaining boy to be chosen out of 5. Since Tim is already chosen, there are 5 remaining boys. And again, it will be a number of combinations, 1 out of 5. And again, it's multiplied by, Anna is already chosen, so we need 1 remaining girl out of 4. So number of combinations, 1 out of 4. Number of combinations 1 out of n is just n, so it becomes 5 times 4, it's 20. C. What is the probability that the team includes both Tim and Anna? In general, we know that the probability is the number of favorable outcomes divided by total number of outcomes. Here, what is the number of ways both Tim and Anna to be included? It's actually the answer for B, and the total number of ways it's the answer for A. So the required probability becomes 20 over 150, it's 2 over 15. D. Fred is the oldest boy in the club. Given that Fred is selected for the team, what is the probability that the team includes Tim or Anna but not both? There are 2 ways how to solve this problem, using probabilities and using combinations. So we need probability Tim or Anna given Fred is chosen. And we know a formula for conditional probability. There must be this connected by and in the numerator, so it becomes probability Tim or Anna and Fred, or provided that Fred is already chosen, divided by the probability of given, so probability that Fred is chosen. But Fred is already chosen, and probability to choose Fred is 1. So it becomes, how to represent T or A? It can be represented probability T and not A, and also provided that Fred is chosen, plus probability not T and A, and also provided that Fred is chosen. Let's find probability that T is included, or probability of T. Since we need 2 boys in total and Fred is already chosen, we need only 1 boy to be chosen. It means we have only 1 trial, and to choose Tim on 1 trial, it will be 1 out of 5, because 6 boys in total. Fred is already chosen, so 5 it's the remaining number of boys, so the probability to choose Tim is 1 out of 5. So probability of not T, it's 4 over 5. Let's find the probability to choose Anna. We choose 2 girls, so Anna may be chosen on the first trial, and the probability to choose Anna, it becomes what? 5 girls in total, so it's 1 over 5. To choose not Anna, 4 over 5. So Anna may be chosen on the first trial, so it's 1 over 5. Or it's plus Anna may be chosen on the second trial. It means that not Anna on the first trial, 4 over 5, and probability to choose Anna on the second trial, it becomes 4. It's the total number of girls, remaining number of girls, so it's 1 over 4. So it becomes 4 over 5 times 1 over 4. So it's 2 over 5. And hence probability not Anna is 3 over 5. So it becomes T and not A, so it's 1 over 5 times 3 over 5. This F, it's like provided that this information is already included, and probability of T and probability of A are calculated, provided that this is true, provided Fred is already chosen. So we don't need additionally to, or actually it's 1, because probability to choose Fred is 1, because he is already chosen. Plus probability of not T is 4 over 5, multiplied by probability of A, it's 2 over 5, and in general it's probability of F, it's 1, so multiplied by 1, and we can see that it's it's 11 over 25. And let's get this result using combinations, and formula will be actually the same, but we will do it in terms of combinations. So the denominator becomes a total number of ways to choose 2 boys out of 6 and 2 girls out of 5, provided Fred is chosen. It's according to this formula or conditional probability. And since Fred is already chosen, we need additionally only 1 boy, and the number of ways to choose 1 boy out of 5, it's number of combinations, 1 out of 5. and the total number of ways to choose 2 girls out of 5, it's number of combinations 2 out of 5. And we need Tim and not Anna, provided Fred is chosen, or so it will be plus not Tim, Tim is not included, and Anna, provided Fred is chosen. So number of ways to choose boys, it becomes what? We need 2 boys in total. Fred is already chosen, but here we need Tim. Tim also should be chosen, so it's only one way to choose 2 boys, provided Tim and Fred should be chosen. So it's only one way, only one possible team, which consists of Fred and Tim, multiplied by its and, because we need 2 boys and 2 girls, but provided that Anna should not be included, should not be chosen. And what does it mean? Since there are 5 girls in total, if Anna cannot be chosen, so we will choose out of 4 remaining girls, and we need 2 girls, so it will be number of combinations 2 out of 4, plus not Tim, but Fred is already chosen, 2 boys in total should be chosen, so we need 1 remaining boy should be chosen, but it cannot be Fred, it cannot be Tim. It means there are 4 remaining boys and we need only 1 boy, so it will be a number of combinations 1 out of 4, multiplied by a number of ways to choose girls, but Anna should be chosen, team of 2, and Anna is already chosen, so we need 1 more girl, so 1 girl should be chosen out of 4 remaining girls. 5 girls in total, Anna is already chosen, so it becomes 1 out of 4. So absolutely similarly, but in terms of ways, number of combinations. And let's calculate. Combinations 2 out of 5, 5 factorial, 2 factorial, 3 factorial, 4, 5, it's 10. So it's 10. Combinations 1 out of n, it's n, so it's 5 times 10. Combinations 2 out of 4, 4 factorial, 2 factorial, 4 minus 2, 2 factorial, 3, 4, it's 6. It's 6 plus 1 out of 4, it's 4, multiplied by 1 out of 4, it's 4, 4 times 4 is 16, so we get 22 over 50 or 11 over 25, the same result. And that's all for this question.